Hi, everybody. So hopefully you're going to see a tree in a second. There's a tree just behind that big grey box. You can see the top and bottom of it. It's a tree that I made with Vasily Abramovich and Baz Overveld. It's a project built around collaboration between scientists, a physicist, and architects and artists. And it's kind of what this talk's going to be about. Let's see if we've still got the grey box. We do. This Vasily is hiding behind the blue box that's on screen in a moment, and it's another image. So go down to École Sainte-Marie, and you will see the installation there, and then come find us and tell us what you think about it. So this talk is all about anti-disciplinary. It's actually about anti-disciplinary. So anti-disciplinary is about something entirely new. It's not about transdisciplinary or interdisciplinary. I was asked to give a name for a talk, and I thought I'd use something that I've never talked about, but that I feel quite strongly about, and it might help me to maybe think about it for a little bit. And I just this morning handed in my PhD that took me 8 years to write. And quite a large amount of that was a miserable experience for me. And so this talk is a little bit about academia and how I work in academia. I have a full-time salary from academia. I'm actually incredibly proud of where I work and the institution that I work for. But I have issues with academia. You know, I've tried to sort of develop a sort of anti-disciplinary approach to working within a university and tried to develop, I guess, my own words and my own frameworks and methods to develop work. So I'm going to show you some of my own work, and I'm going to show you, so this is actually a bit of an image of a piece of work that I did at the Tate Modern in 2012. And there's actually most of this image is black, so it's actually not too bad. You've got about 90% of the image. There's essentially a floating illuminated triangle in the air and a person's head at the bottom. This project actually involved, oh my God, now it's even, okay. This is awesome. Okay, so there is actually, this project was involved puppeteers and animators. It involved architects and programmers. It was my last solo art project, and it was in 6 years ago. And I've never worked as a solo artist since, because I prefer to collaborate. And I discovered that probably the hard way. But this show at the Tate was pretty important to me, and I will talk about it. But I use it more as a backdrop to make a point about how I think most academics are judged by how many times that they are published in prestigious and peer-reviewed journals. So when I did my show at the Tate, suddenly everybody at my institution went, oh, you do something important then, probably. But when I was showing work at, not even Ars Electronica, or I'm talking like the festivals like this, they'd be like, what is a digital media art festival? What has that got to do with you being, worth taking seriously? Get the show at the Tate, bang wallop, I get myself my own research lab at a university. So, it was important for me in a funny sort of way. It was a form of peer review. But a lot of academia, sort of straight academia, involves peer review, usually by a very small influential set of members of your field reviewing your work and deciding what's important and what's unique. And my work doesn't often sit very comfortably inside of institutional frameworks. And what this sometimes means is that the kind of structure of academia leads to a sort of dynamic where researchers focus on impressing a small number of experts and don't take necessarily very high risk or unconventional approaches as a result. And so there's this cliche about academia where academics learn more and more about less and less. And it causes a kind of hyper-specialization. And that ends up meaning that people don't know how to collaborate with each other as well, and less able to communicate, particularly with other fields. So this project was a project with a physicist, and another architect and myself. And it was an exploration of collaboration across disciplines. And everything I'm going to show you is trying to do something across disciplines. So, but this is the lab that I got to run after the work I did finally made sense to people I was surrounded by, I guess. And this is just a picture of the lab and the kind of work that we do. And I'm going to show you some more of this work in a second. But you can see all of it's very physical. We work with performers, we work with light, we work with robotics, we write code, we collaborate with machines, we make machines. So I'll show you more of that. And I'll show you this at the end, actually. So I work within the School of Architecture, and architecture has a certain connotations, and I came to it a bit late. I'd actually had a background in digital media art at the University of Plymouth on a great course called Media Lab Arts that got shut down because it was probably a little bit too ahead of its time, and now we're seeing a lot of new interdisciplinary programs starting up. But that sort of precipitated me going into architecture, trying to find a place to continue my work. I discovered that architecture actually in certain schools of architecture have an incredibly experimental attitude and create a very large platform for different kinds of work. And so I got really interested in the fact that the oldest surviving piece of literature in architecture has an entire book dedicated to machines. So, you know, things like cranes and hoists, pulleys, catapults and sort of siege machines, sundials, performative automata, steam engines, things like this. But the very first book in architecture has an entire, or the first sort of set of volumes in architecture has a book dedicated to machines. And I was like, that's the bit of architecture that I want to explore. And it's actually a bit of architecture that, because of professionalization and because of certain structures within academia, has actually been vented and handed over to a completely different discipline. So it's about kind of reclaiming perhaps bits of machine making to architecture, or maybe trying to make architecture more of that kind of very broad church that it probably once that it was once. I'm more recently, because there's no point just looking back at the earliest piece of literature in architectural history, I got really fascinated by the work of cyberneticians. This is Gray Walter, Norbert Wiener, McCulloch and Ashby. All of these four people were fascinating because they just didn't care about notions of disciplinarity at all. If anything, cybernetics was that ultimate meta-discipline. It abstracted all notions of materiality. It abstracted, what was alive and what was not alive, and what they had to do with each other. And so, we're going to see a lot of machine learning and neural networks. Well, we can thank McCulloch for a lot of that. Early understanding of stimulus response mechanisms in the brain. Gray Walter, Ashby. These are. Wiener, of course, coined the phrase cybernetics, but these people just they precipitated a whole series of really incredible moments of thought at that period in time, that then, of course, academia cut up into slices and handed over to psychology, handed over to to computer science. Well, they created computer science, robotics, and so on. And so these things get chopped up. And then again, these things can't speak to each other. So, a lot of my work has been actually looking at how robotics, when it starts to be used with other types of ideas, can be more interesting, more aesthetically pleasing, and perhaps more useful as well. I also like the way that cyberneticians would do research. So this is Gray Walter having a smoke in his living room with one of his robots. And there's a sort of a relaxed nature to this kind of academia, that there's a sort of sense of playfulness that I felt perhaps sometimes gets lost. And also a willingness to take themselves outside of their comfort zone. So Gordon Pask, he built the Colloquy of Mobiles, which was this set of series of rotating dancing objects that were in the Cybernetics Serendipity exhibition at the Institute of Contemporary Arts in London in 1969. Gordon Pask had come out of doing a PhD in mining technology and then started building machines that learn, and started building machines that performed, and ended up working with artists and architects, and eventually actually having a profoundly important influence on people like Negroponte, who started the Media Lab, at MIT, and then also at the AA and at the Bartlett, introducing notions of responsive and interactive environments and architecture to a whole new generation of architects. So those are the kind of people that I became very inspired by and started building machines. And so this is just background material really for showing you what my practice is like. It's essentially a process of making machines, working with machines, machines making machines, and so understanding tolerances and understanding materials and breaking things and trying to break them enough times that by the time you get to install in a gallery or a public space, you've understood what the likely failure points are in a project so that it doesn't fail when the client turns up, if it's a commercial project or commissioning body or whoever who's turning up for the party at the end. And so this just gives you an idea of what some days are like. And there are only a few days like this. A lot of days are in the lab working at a much smaller scale, but there are these moments when things suddenly pop up, like the tree we've got here at KIKK. I show this actually because I wanted to just say how this kind of practice has really shaped the way that I am as an educator now. And most of my time is spent now teaching. The work came initially from looking at machines, but thinking like, how could a machine interact with a body in the way that one body can interact with another? So I love this image because I think there's a moment which captures true interaction where, just to explain the photograph, there are two fencers. There's a long exposure, which captures the movement of the light at the end of the foil at the end of the foil. And then there's two flashes, one at the beginning and at the end, that captures the position of the fencer. So what we see is the line drawn at the, thank you very much. The line at the top there, where there's a little wobble. And just at that moment, I think there's interaction. And I think it's interaction because it's two bodies, they're acting, they're reacting, and they're adapting their behavior at the same time. So there's not just a kind of pre-choreographed movement going on. It's not, it's actually generative, responsive, adaptive in real time. And this for me is really true interaction. And I use the metaphor of the dance, or the analogy of the dance, to try and explore interaction. For me, that's true interaction. So I got interested in work like this. This is Hod Lipson's research, where they're looking at how you might be able to build machines that are able to essentially explore and understand their own physiology, and once they were able to kind of move around, understand the agency of each of their limbs, that they can start to develop strategies to move. So these robots are not pre-programmed, but they develop strategies for movement. And this was something I was looking at the time that I was a master's student, and it really, really, for me, it was like, that's it. That's how I want to look at designing architecture or environments, is to think about things that have that ability to develop their own character. And what's amazing is when you pull off one of the legs, how it develops a new strategy. And it's an extraordinarily emotional strategy, because you can really feel, right? You can feel the starfish, because it looks like a starfish. The starfish is really struggling, but it's hopping, it's trying to get somewhere. And there's something very interesting about that this is not aesthetic. This is deeply aesthetic. This affects you, even when it's filmed like this. But drop the lights, put a bit of a spotlight on it, and do that, and it's actually would even become more aesthetic. So these are things I've been thinking about for a very long time. Hence, 8-year-old PhD. Anyway, so I got interested in robots that are about as intelligent as very small creatures. And the first learning robot, a bit of machine learning I did was 10 years ago now, as a master's student. And it was 4 of these creatures suspended in a gallery space, turning around, looking for people to perform to. And they found somebody. They had these little cameras hidden in their heads. They found somebody. They would turn and start to flick these tails of light that they have. And they would generate these performances from a genetic algorithm. So essentially, there was a gene pool of performances. Each performance would be played. The success of that performance would be measured by facial recognition. Very primitive facial recognition. Was really hard 10 years ago. And now it's dead easy. My students, I'm like, yeah, just plug this together with this Arduino shield and you've now got face recognition for your robot. It wasn't like that so much then. And so we put this into galleries, and it took me around the world. So I got to exhibit this in many places, including in Brazil, at Itaú Cultural. And here it got to run for about 3 months. So it got to perform to tens of thousands of people who came visitors to the gallery. And it was the first time I've ever left a piece of work in a gallery, went off on a nice little holiday around Brazil, came back, and my work had changed. Each of the 4 robots had developed some kind of characteristics, which was exciting for me aesthetically as an artist. But actually, what really touched me at that time was the conversations I had with the people who worked in the gallery, because they'd actually named each of the robots and would talk at some length about the individual personalities of these 4 robots, way beyond any of the code that was inside of them, or any of my ideas about what the possible behaviors might be for it. And it wasn't because they had, consciousness had emerged in these 4 robots. They were still extremely stupid. But that people were willing to imbue so much life into things that had purposeful behavior, that had certain kind of qualities of movement. And so I had to find out why. Cue the beginning of a PhD, younger, slimmer, Ruairy, chatting to Ronnie Ledru, the founder of the London School of Puppetry, really, I think, one of the great puppeteers of the UK. Anybody from the UK who was roughly my age might remember Rainbow. He was the hand inside of Zippy, but actually incredibly accomplished puppeteer. And we had these strange conversations where I was showing him robots and he was showing me bits of marionette performances. The other thing that I got very interested in was perceptual psychology and the research, and actually most of the research came in the late 20th century, but this was very much ahead of its time. Hyder and Simmel's experiments with moving geometry around and looking at how the interrelations of these moving geometry create very strong effects of perceptions of agency. And what was very interesting was that when they showed this to groups of people, people would often all have the same kind of narrative experience of these animations. I'm going to take a drink of water and you can watch a little bit of it. So what's so interesting about this research is that people would be able to give attributes of and intentions, goals to these rigid objects based solely on their patterns of movement. And that people would actually be able to say this one was angry and this one was happy, and could talk at some length about such simple gestures, such simple movements. And it tells us something about the human imagination. The other bit about this is interesting, is how irresistible it is. Like, I just try not looking at that and thinking of those as living things. It's extremely hard, which again is really interesting. And the fact that it's quite aesthetic. In fact, I'm always kind of stunned by the fact that this work is so close in some ways to sort of, early 20th century avant-garde experimental animations and bits of kinetic art. So there's sort of interesting neuroaesthetic theories about that, which I won't go into today. But I was building bad prototypes early on, trying to think about how I might animate these kinds of geometry and start to create a sort of architecture out of it. And it turns out that trying to build marionettes of robots is a really bad idea, because marionettes work because of the craft in human manipulation. But I did start to get very interested in rigid body dynamics and puppetry, and started working with Delta robots, which were a great little new type of robot that came along about, is it going to play? That came along about, well, they've been around for a very long time, but the copyright on them, patent infringements, expired, so anybody could build them. And so I got pretty busy building Delta robots as soon as they did. And the first one was brought to the Centre Pompidou in Paris, was commissioned to be part of a This is the Picasso gallery, and it was commissioned as sort of artwork that was supposed to respond to the surrounding artworks. And it sort of did, I suppose, but it was very much my opportunity to get some funding to just build a Delta robot and to put it in this kind of context. That's Happy Ruairy. And what was quite distinctly different about this piece of work was that this very primitive machine actually didn't have any AI or machine learning. It just mirrored people's movements. So if you came up to it, there was a bit of footage in a second that sort of demonstrates this. If you kind of creep towards it, it'll creep towards you. And so there's just a mirroring action, which also I think is kind of interesting in notions of empathy and how empathy comes from actually mirroring each other's gestures. So this is this moment when this person sort of creeps up and it creeps up to him. So these were experiments that essentially led to me getting an invitation to do a show here. This was around the time that I got commissioned. There's now a huge big building here. This is the back of the Tate Modern in London, of course, and commissioned to put a piece of work on in the bottom tank here. So these tanks were the oil tanks for when the turbine hole had a turbine in it, and the Tate was a power station. And these spaces actually been left completely dormant for a couple of decades. So this was an opportunity to bring those spaces back to life. And so the idea was to bring a light into that space that would illuminate the galleries, reveal this hidden part of the Tate's history, and then interact with the public and show them around. So I got the commission, and again, I was working with this idea of very simple geometry and trying to create some kind of visceral response to it. And the work was called Fearful Symmetry. It's a line from William Blake, and I wanted to kind of create some of the atmosphere of that. So that involved working with animation techniques to try and imagine the movement of a light inside of that space and the way that the public might move around it. And then there was the challenge of building a robot for a space that's 7 meters tall and about 30, the motor was 21 meters motorized rail in a 30-something meter space. It's about twice the width of this auditorium, essentially. So it's how do you build a piece of kinetic art that's going to be able to inhabit such a large space? So I had to build the largest Delta robot that had ever been built for that time, and then put it on a 21-meter motorized rail. That was basically the answer to that question. And then I had to find a light that didn't have the feeling of being a light. So I found electroluminescence sheet, which creates a perfectly flat white light, and you can laser cut it, which meant I was able to start to work with it like a piece of geometry. And so these were the insides of the heads, and then this is the head itself. And then this is the actual, this is the test Delta robot. This is a quarter-size robot, and this just allowed us to test the movement. Now this is about a month before the show opened, and we were still quite some way to go, and I'm starting to say we now, because I'd suddenly realized that I don't have to do everything in my life alone, which was quite a late realization. And I started to look around for help when I realized I wasn't going to get it done in time. And people said yes, they'd be interested in doing it, and so I built this team very rapidly. And let me see if any of them are in here. This is just the actual, that's the Delta robot there. That's me, that's my robotics engineer. That's my brother, actually. And this is, just grabbed everybody I possibly could. And to the left, to find a space to do it, I actually found a space where they build about half of the Notting Hill Carnival. So this was my backdrop to building it. And this was the team that was assembled. And I never, ever went back to working alone again after this. When I started to realize that collaboration, it's not just about handing jobs off to other people. It's so much more than that. But I first got to work with a robotics engineer, so I stopped having to be the robotics guy as much. Emmett in the back, he's a sound engineer. Ollie Palmer, he's now teaching in the Netherlands as a interaction designer. So anyway, there's a bunch of people involved in it. I'll just show you, this was the install at the Tate. We only had 1 day to install. There's a motorized rail, and then you can see the body of it, all completely black, so that when it was actually suspended and the lights were turned off, nobody would get to see the 21-meter motorized 5-meter tall robot that I'd spent a year building, they'd only ever get to see the light. This is just the install there. The BBC came down and started covering it, which was great because I didn't have time to document my own install. You can see just how high up we're working and all of the challenges that came with that. And this is it suspended, and then this is it when the public came in. And so if you go into the space and you stand motionless underneath it, it sort of hovers above you, inanimately itself, kind of mocking your own inanimacy. And if you start to move, it feeds off that movement and plays that back to you in a kind of abstract manner, and that creates this sort of sense of a sort of conversation going on, although again, the algorithms are extremely simple. And then there are certain moments where it might run away, and there are moments where it might start to spin around people and be playful. There's a bit of footage of a piece when it was shown in, this was shown in Brazil just last year, and it was a smaller exhibition, so the manipulator was changed. But it's just to give you a sense of the footage quality is a hell of a lot better than the footage from the Tate. But I have got some great footage from the BBC of the response of the public from the Tate, which hopefully...
And me of being in one of those scary films.
It reminded me of one of those dreams you have, when aliens sort of invade the
Okay, video's gone weird again.
Seems something like that.
But you can hear.
The triangle light came on and it appeared to be following people.
It kind of creeped me out how it knew how people were standing and where they were.
You could see the reactions of all,
It's a
all
bit
the
creepy,
other people.
yeah.
They weren't quite sure what was going on.
Yeah.
You expect something a bit scary, but then, I don't know, its movements are kind of organic, and I don't know, it seems very friendly.
So there's this, let's see what happens now. Yep, so there's this moment where you go in and there's this kind of, at first impact, you go into the dark, and there's this kind of intimidating moment where this sound is playing, and you don't know what's going on, and you start to see this light moving, and you don't know, and there's this kind of, I think there's sort of, your probably heart's racing a bit, and as you actually get closer to it and you start to play with it, there should be this kind of emotional shift, and I see the drama being in that sort of pulling somebody from one end of a sort of emotional spectrum through to being playful and happy and enjoying themselves. And so this is my favorite image because it's this moment where a father is lifting his child up to reach out and make contact with this alien creature, which is also extremely dangerous because that is essentially a flying spike that I've got operating in the air. But it's health and safety security guards are just out of shot actually on either side, coming on a pincer maneuver. That's a cropped photograph. Let's skip this. We got 15 minutes. I want to show you some of my students' work. So this is, stop that. So I, this process, some of these processes of learning to collaborate, learning to work with different disciplines, asking questions that don't sit within a sort of a single disciplinary area, but actually sort of potentially require you going to perceptual psychology and puppetry and architecture and theatre, and asking questions about phenomena and aesthetics that are irrational to some degree. I find really, really fulfilling, and I'm very, very lucky to be able to build a lab and to work within a sort of disciplinary environment, but to be able to do that with complete freedom, which UCL and the Bartlett definitely does. And the context of being given this opportunity is, of course, the idea of the internet becoming increasingly physical, and we're all being more connected, and background video footage for me to explain that the things that we're carrying, the cars, the footage, the kind of transportation networks, the infrastructure of the cities, the buildings themselves are increasingly connected. So how do we teach people about that? How do we, Arduino, Raspberry Pi, etc. And then there's also, of course, this strange animacy that's coming to our environment. So now the digital is becoming physical and becoming motive and embodied. And so these create strange emotional responses in us that make us feel strange. So what are those things? How do we deal with them? How will autonomous vehicles change our cities? What will their personality be? And then, of course, there's this digital layer. This is the work of Keiichi Matsuda, a former graduate of the Bartlett, exploring digital layers that might sit on top of architecture, create completely new realities, or mixed realities. And so to teach and explore these ideas, we teach our students to program, and we work with open source tools. So we teach processing to all of our students the first day that they arrive. And so this is some stuff that one of my graduates, Felix Fair, who's now a professional digital artist, doing great work. This is his work with me while he was a student on an installation that then went live. This is the Balls installation. It was built for Arup's headquarters in central London. And part of that project was not just putting this kind of the what's it called, the kind of gallery atrium. What's going on? Oh, okay. This kind of atrium art, I'd call it. It's sort of polite, suitable for corporate contemplation. But it also was a way for us to kind of go into Arup. And Arup's the UK's largest and leading engineering firm. And so it meant that we could actually do workshops with Arup engineers with our installation as a platform, not just a kind of art project. So we taught them the software, we called the installation Balls, and we built basically a little tool that they could hack that allowed them to take over the installation in their atrium. So that would be everybody from engineers to the security guards, facilities, were invited to come to that. If you could program, great. If you brought some tools you wanted to use, great. If you were, you're responsible for security and you couldn't program, perhaps, then you might just come and say, I would like to try and do this, and we brought students to help. And just to give you an example, one of the guys who turned up there had a leap motion, magic leap motion. Essentially allows you to track hand gestures, plug that into our computer, run our software, and now just by using your hand gestures, you had kind of godlike control over this light canopy going up and down inside the building. So these were nice ideas that were beyond my expectations for the installation, and sort of encouraged people to start to take control of their own building in different ways. And it's kind of important for me to drop those ideas into an engineering company that designs more intelligent buildings than more or less anybody else in the country. Like, how do we democratize access to those building systems? But that was my other agenda. And this is Felix's work that came out of it as well. So then he went on to look very different work, but just to share like where his own graduate projects went. So the sound and the audio is a little bit out, but that's not because of it was extremely responsive, but I think it's just the playback here. But but just to give you a sense of more of a sort of digital end of the spectrum of the work that I'm doing with students, Felix then went on to do a lot of other great work. So this is just him talking a little bit about how this work is manifested in a TEDx talk that he did. So I'll just share. This is a little video. If you go on our website, you can see videos of our recent graduates and what they're doing now. There's quite a range of different kinds of places they end up.
I'm currently a freelance computational designer working with companies, particularly in architecture, technology, music and art. My master's thesis was about using structure-borne sound as an interaction medium. So taking the information of sound traveling through materials to create interactive surfaces from timber, glass, architectural materials. So I'm particularly interested in our experience and perception of sound and image and motion and the sense of touch as well, our sort of haptic experience of our environments. So I've been working very closely with some companies that create musical interfaces for composers and producers and musicians but also working on some projects that are more sort of architectural scale as well, that incorporate full body motion tracking, art installations, or live stage performances as well. I was recently given the opportunity to give a TEDx talk about the research that was done at the Interactive Architecture Lab, and my particular interest in our senses of sound, sight, and touch, and how they are sort of combined and come together in the brain to create these new types of experiences.
So there's loads of those videos on the website, and for those of you who might be interested in doing a master's program or might just be interested in telling somebody else about master's programs, you can go and check those out. This is just some background as well to how I started to introduce machine making to students as well. So there's software here, there's mechanical design, there's this kind of strange ferrofluidic frame that's able to start to move around on a wall. And now you take that system and you plug it into an industrial robot arm that you have lying around. And then you're able to start to essentially, this is kind of Victorian tricks in a way, but to magnetically manipulate this frame on a wall. And so there's just, and so this frame has a little pinhole camera inside of it, so it can actually see people's faces, and it can mirror your expressions back to you in a very abstract way. So these kind of little playful moments of how you might animate architecture, I think, are one of the things that we're really interested in doing. Little bits of magic. Something quite different, because there's quite a few different little projects. I've got about 5-6 minutes. I just want to share with you some student projects, just to finish. This is, you've probably seen a few projects where people sensing off plants. There's a lot of capacitance sensing, which is kind of interesting only up to a certain point, but we were looking at plugging electrophysiological sensors into plants to essentially kind of tap into their primitive sort of intelligence. What we were able to do from that was to measure sort of information gathered from the environment and use that to drive a garden. So the garden that we conceptualized is this garden that's able to be populated with different species from Kew Gardens. Those species are then essentially electrically polled for their responses to different kinds of environmental stimuli. And weather, humidity, sunlight, and so on. And with that, they're able to collectively start to make decisions about the orientation of the structure, or where it might travel. And so this is just a little taste of the structure itself shifting one of its garden modules out to shift its center of gravity so it's able to roll over. And so the structure, collectively, these species might start to be able to travel around London very slowly and find microclimates that suit certain types of species desires, and then perhaps maybe plant there, who knows. So this is a project that dealt with sensing plants and trying to imagine how that might give us information that we could use to control buildings and so on, but it was, we playfully explored the idea of it as a autonomous system that might be able to start to inhabit the city. That's on its way from Camden to Euston, I think. So a couple more projects. I've just got time, I believe. I get students from very different kinds of backgrounds. I often find students coming to me who don't feel like they fit into the kind of pigeonholes that they've been given to. So I get quite a few non-architects coming to the program. We've got dancers coming to the program who are interested in space and working in a kind of architectural environment. I've also got architects who happen to be dancers in their, almost as a hobby, but it's actually their true passion, and they're interested in how to maybe bring those two worlds together. So this is Shuko Kato's work. This is not Shuko Kato. This is obviously Laban notation. But she got interested in how we might start to capture movements and to build abstract representations of it. And so we went about building a rig that allowed her to track her body movements. Those body movements were translated into very simple geometric expressions. So this is just capturing these movements. Those are getting put into parametric software. A very, very simple representation is built. Those are then these aluminium tubes are handed to this manufacturing system that builds and bends these tubes into different types of shapes, and then hands them to Shuko, who then puts them into the space. She then dances with that bit of space. That then generates more geometry. The robot assembles more geometry, hands it back to Shuko. Shuko then brings that back into the environment, and then it starts all over again. She performs, the robot interprets it, builds more, hands it back to her. And so there's this feedback loop between the architecture, the robot performer making, and then Shuko performing and making as well. And this could go on endlessly, but essentially it sort of builds up and builds up and builds up, and increasingly the architecture starts to define the kind of paths and movements that Shuko can perform. So it's a type of spatial notation or dance notation. It's a type of design, it's a type of fabrication, it's kind of a bunch of different things, and none of them really at the same time, I suppose. Now that's a very rigid robot, working with very rigid materials, but I've for quite a long time had a real fascination with soft robots, and I guess a lot more of this stuff's come out recently, so you might have started to see bits of this. And I've been playing with it for about 7 or 8 years now, with different students, and seeing how big we can get them and how small we can get them. But there's something really amazing, just to bring me back, I guess, to some of the stuff I was talking about earlier on, about the way that these materials make you feel when they move. And so this is, fun and creepy, and it's just like a really quick experiment. But there's something compelling about the way that these materials behave that's different to kind of robotics that we think of. And I think this is the way that robotics is going. It's becoming softer, and it means that we can start to imagine it being closer, much closer to the body. And this is just an expression of that in, so depth perception cameras are expected to be, well, we've already got them in our phones, but they're very soon going to be in more or less every phone. So what happens when, see what the camera did to kind of culture, what would 3D cameras do? What will it be like when everything has a 3D camera, it's tracking its environment? What's that going to do to, what kind of possibilities does that create for interacting with space? And so this project started to look at that in relation to soft robotics, and how a certain kind of soft robotic membrane could be on the body that allows the 3D scanning of the world to start to arrive and affect our body physically. So these are experiments that the students did, and just to give you, this is just some of the background. This is just some of the very kind of material practices that the students are doing. And then they're building these machines, and they're actually doing experiments with them. So this is the sensing being actuated onto these air muscles. And essentially what this allows you to do is to be able to walk around with a blindfold, but be able to feel space, the pressure that's on your skin. So the applications could be potentially for people with limited sight, whether that's something they're born with, or whether it's because of the conditions of the environment that they're working in. And so they started to do a series of experiments with that that demonstrated some really interesting things about how we actually experience space that's been written up as a paper for a cognitive neuroscience conference at the moment. And these are the experiments they were doing. I'm not sure if this at the end shows the results of the, yes. And then one of the parts of the project then was to see if we could take these experiments, which are really, really interesting, but perhaps not that interesting to certain audiences because they're not so visually arresting, and explore the use of filmmaking and storytelling to deliver a message. And so this is actually the work then developed a sort of short speculative film which imagines a near future where perhaps beyond the mobile phone we start to have these soft fluidic interfaces that mediate essentially our experience with the world outside, the kind of networks that we have, and sort of reveal physical or invisible layers of information that are in the world around us. So starting to use performance as a way to express ideas and technologies that might be quite hard to otherwise appreciate. And so that's where how long have I got? That means no minutes, I believe. And that's where I ended up. Building this program called Design for Performance and Interaction, which I just want to finish. These are the guys who helped me build it. This is a picture of happy students. This is the website, interactivearchitecture.org, if you want to find out a bit more about it. And I think I've run out of time, so thank you very much for your attention. Okay.